There are two ways in which nucleophilic substitution takes place in alkyl halides. The first is called SN2. SN2, well, that means substitution nucleophilic bimolecular. Bimolecular, that's why you have the 2. And the other is SN1, that is substitution nucleophilic unimolecular. Fine. Now let's see how the SN2 mechanism proceeds. Now before we discuss the mechanism, well, we first need the reactants, that is an alkyl halide and a nucleophile. Let us take chloromethane and hydroxide ion as the reactants. Now, in SN2 mechanism, the nucleophile approaches the carbon atom, and as the interaction between the carbon atom and the nucleophile begins, the bond between carbon and chloride starts weakening. Then a stage comes where the carbon atom is attached to both hydroxide and chlorine atoms with equal strength. And this stage, well, this stage, as can be figured out, is known as the transition state. The transition state is very unstable, as in this state, carbon is simultaneously bonded to 5 atoms. Now the carbon hydroxide bond keeps gaining strength, while the carbon-chlorine bond becomes weaker and weaker and eventually breaks. Now, observe that the configuration of the carbon atom before the reaction is different from its configuration after the reaction. Why does that happen? This happens because the attack takes place from the backside. So, SN2 mechanism causes inversion of configuration.